David Smith here with another flipped classroom math lesson. 3 tips before we start. First, you can adjust the playback speed if that helps you get through the video. Second, you can pause the video at any point to take notes or work the examples. Third, you can turn on the captions and read my words go by on the screen. Today's topic, simplifying trigonometric expressions. So we're going to work these expressions. We're never going to know what theta is. We're just going to manipulate the expressions. Okay? So the first 2 operations we're going to do are addition and subtraction. And this is super straightforward. So I just got a couple examples for you here. 2 sine theta plus 19 sine theta. What might that be? If you said 21 sine theta, you're right. It's really simple. We just got 2 sine thetas. We're adding 19 more. So this is 21 sine theta. Now, it works the same for subtraction, so see if you can do that one. Okay, I got 7 cosine theta minus 11 cosine theta. This is going to be minus 4 cosine theta. Okay, now let's talk about some problems using the sine squared theta plus cosine squared theta equals 1. This was our trigonometry that we got several lessons back. Okay, now before I do a problem, I want to show you 2 closely related ones. I've taken this expression and solved it for sine squared theta. So sine squared theta is 1 minus cosine squared theta. I just moved the cosine squared theta over to the other side. And the same thing with cosine squared theta. It's going to be 1 minus sine squared theta. So these are handy to know. You don't have to have them. You can always use this to solve the problem. But you'll find these are kind of nice. Okay, so let's do a first problem. I've got 4 sine squared theta plus 4 cosine squared theta. What's that going to be? So maybe pause the video, see if you can figure that out. Okay, let's see how you did. You'll notice there's a 4 on both of these. So I can factor the 4 out. 4 times sine squared theta plus cosine squared theta. Now what do you think we're going to have? Check this out. Sine squared theta plus cosine squared theta, that's this. And we know this is just 1. So this expression is 4 times 1. So this is just 4. Try that one. See what you can get. Okay, let's take a look. Noticing I have a 3 in 2 terms. This is just a 3 by itself, but that's 3 times 1, which is going to allow me to factor the 3 out. So I have 3 times 1 minus cosine squared theta. And this should be triggering a notice for that. 1 minus cosine squared theta is sine squared theta. So this becomes 3 sine squared theta. Now, let's look at using some factoring patterns to evaluate trigonometric expressions. So, if you're not totally up on your factoring, you might want to look back at old notes. I also have videos that explain all the factoring patterns. You just have to let me know, and I'll give you some links to those videos. Okay, so sine squared theta minus cosine squared theta. Okay, so this is not that plus we had before, so we can't just say this is 1. Otherwise, it would be 1. But there's a factoring pattern that deals with this. This is the difference of squared. It's one thing squared minus another thing squared. That's what this is. So if you remember that pattern, this is a plus b times a minus b. If you FOIL this, you'll wind up back here. Okay, so using that factoring pattern allows me to factor this like so. Sine theta, let's do plus cosine theta times sine theta minus cosine theta. Now, that might not appear simpler than this, but it's factored. So we took this, we factored it, and we got that. Now we're going to do a little bit of a more complicated factoring pattern. Take a look at this expression. Sine squared theta minus 5 sine theta plus 4. Now this can be factored. Take a minute and look at that and see if you can see how that might happen. It's a little tricky. It's buried in a trigonometric expression, but it's there. Okay, take a look. I'm going to show you a quadratic that has this same pattern. That would be x squared minus 5x plus 4. So this expression is very similar to this, only instead of x here, we have sine theta here. Now remember, when I write the squared here, what that really means is it's sine of theta squared. Okay? All right, so now that you see this quadratic, this factors rather easily. It's a product sum type factoring. So go ahead and pause the video and see if you can figure out how that factors and then apply that to here. Okay, let's see how you did. This factors in a quite simple way. You need two numbers that add up, or I'm sorry, that multiply to positive 4, that add to negative 5. Okay, and those numbers are -1 and -4, because they add to negative 5 and they multiply to positive 4. So that means this expression factors into x minus 1 times x minus 4. And I'll say again, if this factoring is looking all Greek to you, you might want to review your factoring so you're a little bit more up on that. Okay, so now that I've factored this quadratic, which is very similar to this trigonometric expression, into this, pause the video and see if you can factor this into its equivalent. Okay, so this is pretty simple. We just take the x, and instead of x, we put sine theta in there. So this would be sine theta minus 1 times sine theta minus 4. Now we're going to do some simplifying that's going to use some of the concepts that we talked about just a minute ago. And remember, factoring patterns, we just did 2 in the last examples. There are other factoring patterns that you're going to need to use. Okay, so let's take a look. We need to simplify this on down as simple as we can make it. So my first step, I'm going to notice there's a 3 in both these terms. So I'm going to write this as 3 times 1 minus sine squared theta. I'm going to leave this as 1 plus sine theta. Now, when I have a fraction, canceling is your best way to simplify. But I don't see anything I can cancel right now. This is 1 minus sine squared theta. This is 1 plus sine theta. There's really nothing I can cancel. However, if you look at this term here, this is another difference of squares. It's 1 squared minus sine squared theta. 1 and 1 squared are the same. So 1 is always a perfect square, and its square root is itself. Okay? So that's going to enable me to rewrite this expression as follows. 3 times 1 minus sine theta times 1 plus sine theta. All over, we're just going to bring that down, 1 plus sine theta. Now, if you were to FOIL these binomials, you would wind up back here. This is a difference of squares, and this is the pattern that we put on one of the few boards back that shows how to do that. Okay? And then I brought this down. Now, I see some things I can cancel. I have a 1 plus sine theta here, and I have a 1 plus sine theta there. Since everything here is multiplied, I don't need to worry about finding any more of those. I can just cancel that out. And now my answer is 3 times 1 minus sine theta. Let's do another one. Now, if you want to pause the video right now and see if you can do that, it would be awesome. This uses factoring patterns that we've talked about just a few minutes ago. So pause the video, see what you get with that. Okay, if you noticed that this here is also a difference of squares, it's one thing squared minus a second thing squared, then you can factor the top as follows. Cosine theta minus sine theta times cosine theta plus sine theta. So that's the top factored. There's really nothing we can do to simplify that, so let's just bring it on down. Cosine theta minus sine theta. Okay, so now I've factored the top, and now I can do some nice canceling. I have cosine theta minus sine theta, cosine theta minus sine theta, so these two cancel, and I can finish up by just doing cosine theta plus sine theta. Now that you've watched the video, jot down a few extra notes or questions for our next class. You can also re-watch portions of the video that you didn't understand the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.